Hello friends, this question is from the test series 4 from the subjects of electromagnetic theory and topic name is transmission line. The question says that an airline has a characteristic impedance of 70 ohm and a phase constant of 3 radian per meter. At 100 megahertz, calculate the inductance per meter and capacitance per meter. That we need to calculate the inductance per meter and the capacitance per meter of this particular transmission line. So as you said, that question says that our transmission line is in air and we have a characteristic impedance which has a real value 70 ohm. So if my characteristic impedance has a real value and my transmission line is in air, so my characteristic expression of my characteristic impedance is basically is R plus j omega L upon G plus j omega C. So if my characteristic impedance has a real value, it can attain only real values only in two circumstances. First, the whole reactive element will be 0. If my L in C is 0, then R by G is a real component, then we will get a real value of Z0. Or in otherwise, our R and G will be 0 such that the J omega, in that case J omega and J omega will get cancelled and we have a L by C, so that also will give a output of a real value. Because in our case, our transmission line, we have air line, so air line will must have a 0 resistance. So in our case, the R and G must be equal to 0. So the expression for my characteristic impedance is Z0 is equal to under root of L by C. And we already know that phase constant has a relation with omega as beta is equal to omega into under root of LC. We already know the value of beta as given in the problem. So with the help of these two expressions, I can compute the value of C as beta upon omega Z0. It's a simple manipulation. You can do that and then put the value of beta, which is given in the problem as 3 upon omega is 2 pi f. F is given as 100 megahertz, 100 into 10 raised to the power 6 into Z0 is 70 ohm. So by the calculation, we will get the value of capacitor C as 68 picofarad per meter. Similarly, again manipulation by the help of these two formulas, you will get the value of L as Z0 square C. By the help of first formula only, if you can calculate the value of C, you will get the value of L as Z0 square C. Then put the value of Z0 as 70. C we have just calculated 68 picofarad, 68 into 10 raised to the power minus 12. The value of L can be calculated at 334 nanohenry per meter. So in our case, our correct option is L is 334 nanohenry per meter and C is 68 picofarad. The correct option is option B. Thank you.